So here I wanted just to show some work that has been done lately, and this is just to illustrate how important it is to collect and have the access to high quality and timely data, and also how important it is to have good modeling practices. So the two basic principles we are gonna teach throughout this program that will last 3 years. What we did, like during the COVID crisis, is that we tried to find the most up-to-date and timely data on energy demand. And thanks to that, we achieved to estimate that during the crisis in 2020, or due to the COVID shutdowns that reduced the demand of energy, we'll have a big decrease of energy consumption that is comparable and second only to the decrease that we have seen during the last World War in the 1940s. So this was really interesting to do because the IEA had collected a lot of different data from different sources that are data with a certain level of quality and also data that are really recent. So the fact that many countries had collected and put available, so disseminated good data, and the fact that the IEA had good practices and expertise in modeling and projection, we were able to say and estimate how much the global demand will decrease this year. This, of course, can be a bit different than what we did, but was a good approximation that permitted to plan in advance many different policies and action. So this just to stress the importance of statistics and modeling practices. But now let's go to speak about energy products, since today we're gonna see all the different ones and how we report them. As you can see, this is the total primary energy supply. So it is the energy available in a country to be consumed, transformed, etc. And we can see it for the different regions in the world. You can see our OECD and non-OECD, and easily you can spot that for the OECD at the left side, 80% of the energy supply is fossil fuel. So natural gas in orange, oil in blue, and coal in gray. And similarly also for the global non-OECD countries. As you can see, more or less also 80% is the same. But if we go to Africa, we change a bit the figure, and we see that only half of it, of the total primary energy supply, is made of fossil fuels, because the other half is mostly done and covered by biofuels and waste. If you go to sub-Saharan Africa, this increases even more, where we can see that more than 70% of total primary energy supply is biofuels and waste. And even more in Ethiopia, as we know, almost 90%, I think, or close to 90% is biofuels and waste. This in Africa is mostly due to the traditional use of biomass and charcoal as well. That brings a huge consumption that is even bigger than the consumption of more modern fuels like electricity, natural gas, sorry, not electricity, but natural gas, oil, or others. And as you can see, for Ethiopia, the importance of biofuels in the energy mix is very, very, very high. It's practically the whole of the energy consumption, it's 90%. Now I would like to just see again how data are collected and where they can come from, just quickly to sum up what you've seen in the last sessions that now sometimes passed, unfortunately, because of unfortunate events. So what are our sources? We have supply and transformation data. That means data that can come from energy industries and producers, but also from importers and exporters. For example, in Ethiopia, imagine you have companies that import finished oil products that are used by cars, for example, gasoline and diesel. And these companies has important data on the imports and sales of these products. And this can be collected and used for compiling energy statistics in the countries. Then we have the demand data, so the energy consumers, so the people and the industry that consume the energy. And here we can see on the other side of the picture how much energy is directly consumed in the different sector. And it can be done by using surveys, for example, in the household, to understand what people are consuming in their houses, or also to enterprises to know how much electricity or how much of other fuels they are consuming. And late at the bottom of this slide, we have the integrated approach that is both using surveys that exist. For example, you have already an household survey in your country. You can either use it as it is if it's okay, or you can even add some simple questions to gather some additional precious information with a very low cost, because the survey is already in place, and adding 1 or 2 questions is not a big cost as starting a new survey. We can use direct measurement. This is, for example, for electricity consumption, since we have meters. Or we can use also estimation and modeling. This is in the sense of estimating data that are missing, or covering some gaps in the data for certain years. We have seen, I think, in the last webinar with more details. Now, I think I will let Nicolas continue, but as you can see today, we will see firstly with Nicola, primary and secondary oil products. Then we can see the natural gas energy statistics. We will go quickly to coal and coal products because we know that for Ethiopia is still not an important fuel. And then we'll finalize the today webinar speaking about renewables and electricity. Please, Nicola,
yes.
Let you share the screen.
Oh, yes, hello everybody. So happy to be here with you today to present those 3 main classification of fossil fuel that we are using at the IEA. So I think it was covered already. So why can't I share the screen? I think you saw last time in the previous presentation that we are mostly our work is mostly based on the IRES classification, and we are following the same for the name of those products. John Lucat, why can't I share my screen?
If you go in the bottom, can you see appearing our banner?
Yeah. It just appeared.
Cool.
Okay. There. So I think everybody, you can see my screen. All right.
Yes, very well.
So yes, so we are using IRES classification to, when we talk about oil, it's we group primary and secondary oil. When we talk about natural gas, it actually includes natural gas in a gaseous form and also the liquefied form. And coal, we will see, we group actually a lot of different type of solid fossil fuel, and also gaseous and liquid, actually. So first of all, let's start with primary and secondary oil products. So a part that is pretty important in Ethiopia, actually. So first of all, we start again with a small Menti quiz. So here you should see now the test, our Menti quiz. So the next question will be for you. We want you to try to order countries from the top oil producer to the smallest producer, and that before the COVID-19 crisis, of course, because right now the market might be a little bit changed. But before the COVID-19 crisis, for you, who was the first oil producer and the smallest oil producer in the list of countries below? So for you is who was the first, the top oil producer in the world? So yes, we have the first answer, 2 answers. While you are answering these questions, take the opportunity to do a little bit of advertisement for our products at the IEA. We are publishing also a small booklet that is called the Key World Energy Statistics, and in which we have this kind of information for free available with the value, the big general figures on world energy production and area production. So for those, if you have this kind of question that sometimes could be useful for you on your day-to-day, we have that for free available on the IEA website. So we have 5 answers now. So for you, Saudi Arabia and United States are on the top, followed by Russia, Canada, China, Iran, Nigeria, and finally Angola at the bottom of the list. All right. Alors, when we see the world energy consumption, so Elias, I've seen your question. I will either let John Luther type an answer, or we answer to that after the full presentation, because I think it will be discussed also in the renewables part. All right. So now we should be back to the presentation. So let's see the answer to the question that we just asked you. So the top oil producer in 2017 was actually the United States of America, that they represented 15% of the world production. And then we had Saudi Arabia and Russian Federation that followed. And when we look at this pie chart, we can see that the 10 top producers supplied actually more than 70% of the total oil demand in the world. So that's why, as a political subject, oil and oil products are really important and are subject to many crises and are looked by many people because of that importance of some countries supplying the world. Now, as I told you, when we talk about oil in our data, we talk actually about crude oil and secondary refined oil products. But those are two different products that are actually do not go to the same flow, to the same type of consumption or usage. So if we look at first to the growth of refining that took place in the world. Actually, yeah, there's an issue with the title. Do not pay attention to this. So the input of crude oil and primary oil into refinery in the world, you can see that in the latest years, the growth has not been much in OECD or Middle East or Europe, but the most growth, the increase of world of refinery intake, has been actually in Asia and particularly in China. So both are the part of the world where the refining has been taking place more. At the same time, the growth in oil demand, so we're taking into account all the secondary oil products, has been led mostly again by China and Asia, but also by the other non-OECD countries in the world, like Middle East or Latin America, with their growth of activities. In Africa, we will see soon what was the main source of increase, but you can see that even if there has been an increase of the demand, it's not that much compared to the rest of the other continents. So in Africa, the growth of oil demand has been mostly led by transport demand. The increased number of people using their cars in the continent has been mostly driving this impressive increase of demand in the country, in the continent. And also, as you can see, non-energy use represent a really small share of the oil demand in Africa, because it's mostly used in a petrochemical industry, which is not a sector that developed yet in Africa, but might be moving in the future. But for now, it's mostly represented in the OECD. So now let's talk more about the type of products we can find in oil in general. So the primary oil products, they regroup crude oil, of course, but also the condensates and natural gas liquid that can come from various extraction activities for natural gas or other type of fossil fuel extractions. And you can also have in primary oil products what we call the synthetic crude oil or shale oil. So for example, the synthetic crude oil that is produced from gas, from coal liquefactions, which is something that is happening in South Africa, for example. And also one specific thing that we have in the refinery activity, that you can have secondary products, refined products that are used as input to refinery during the process, and some additive and refinery feedstocks that can also be mixed in all those. On the other hand, in the finished secondary oil products, the refined products, we have some gases that are produced during the activity. We have also various number of other products going from lighter to heavier. So going from ethane, LPG, so liquefied petroleum gases. You have gasoline, kerosene, diesel, and gas diesel, bitumen, paraffin, etc. So a lot of different things, but most of the time are named this way because they have specific physical properties that make them easier to classify. But we recommend always to use the IRS definitions if you have doubts with your sources from the refinery on what type of oil products you are using right now. So now we will go through some charts to explain how we conceptualize and how we try to understand with a balance the value chains for the oil products. So first of all, when we look at the primary oil products, we have the production. So here, for the production indigenous, so from an oil well somewhere in the country, and what we call from our sources, so it could be some liquids from the natural gas extractions, etc. So yes, as you can see, when we talk about indigenous production, and in general for fossil fuel, when we talk about the production in the country, we talk about the production that is happening within the borders of the country, and including offshore production, and also the marketable products, meaning the products when it has been treated already and is ready to be sold by the extractor. So after the part on the production of those fossil fuel, we will then be focusing on the trade of those products. So either exportation or importations. The managing of the stocks, so the stock builds or draw. Be careful there, depending on the methodology that you are choosing, those values can be positive or negative in your tables. It's important to document and to know which definition you are following there. And then you have here various flows that are concerning the either direct use of primary products, that for example, some countries use crude oil as input to power plants to generate electricity. So this can be consumption here of primary products. And there below you have the batch flows and the finished product transfers that are coming from the refinery, which is here. So all the rest of all the remaining crude products, primary products, will go to the refinery. And from the petrochemical industry, you can have batch flows here that goes back and are considered as primary products. On the secondary oil products part, so we start here where we left with the refinery, and supposedly all the output from the refinery, so of secondary products, goes in the gross inland deliveries, which will be delivered to industries, to transport, to private sector, etc. The sold part of the secondary oil products. Of course, it is not that easy. So first of all, some of the outputs of the refinery will be used to power the refinery activity. So we call them refinery fuel. You have the refinery gross output that is considered as the main output for secondary oil products. And you have also the primary product receipts, which will be mostly concerning biofuels, some primary products that are used directly as secondary oil products. Then you have the transfer that we have seen before on the crude part. So transfer, you have interproduct transfer, which are concerning oil products that are reallocated to another use, and the transfer of products that is regarding the modification of properties through a second refinery process. Then we have as primary, after this whole refinery activity, you have either the bunkering of both fuels, so the international bunkering, the delivery to international flight or maritime activities, and you have trade, export or import of both products. Of course, again, the stocks. So once again, be careful with how you report those values. And as I told you, the gross inland delivery, which is concerning energy sector own use, so the consumption to supply the activity of the refinery or other transformation sector. The transformation itself, so the transformation of one product into another. And finally, the final energy on non-energy consumptions. One last point, but I don't think it's that developed right now in African refinery activity, is the recycling of some products from the end use, the final end use and gross inland deliveries. Some products are recycled and re-injected into the distribution system. So when we look now at sub-Saharan oil data sets and what kind of trends we can see on the continent for those products. So first of all, when we look at the oil balance for sub-Saharan Africa for 2017, you can see here that mostly all of the production of crude primary oil, so crude, NGLs, etc., has been actually exported after the production to where we will see after, and there's a very little few refinery intakes that is happening within these regional geographical regions. And actually, this led, so from the refinery intake here, you have the refinery outputs. And to meet the demand, especially from transportation within the continent, there is a need of a lot of importations to meet this demand and to meet this need in the continent. This is explained because of the structure of many sub-Saharan African countries, which I have either supplier, so exporters of primary oil products, but do not have refining capacity, refining structure within the country, and other countries in Africa or elsewhere in the world that have those structure but do not produce their own primary oil products. So there is a balance happening here between who is supplying the primary products and who is supplying the secondary products, which lead to many sub-Saharan African countries to be dependent on their secondary oil products, while they seem, when we look at first at the data, like they are independent in terms of energy productions, which is pretty interesting for us regarding data. When we look now at Ethiopia energy balance regarding oil balance, So as you can see, there is no oil, primary oil supply happening in the country. Neither there are refining infrastructures. In our data, at least if you have a refinery in Ethiopia, please tell us right now, because this will mean we are totally wrong in our data. And then we have all of the oil products demand that is matched by importations, which show, again, as I told you, that when you look at sub-Saharan Africa, you could think that there is an independent, it's not dependent on importation regarding total energy production. And when we look at more detail, especially for secondary oil products, we can see that many countries are actually dependent on their importation, on the trade of those products. So now let's go back a little bit to how we report data and how we check data. And one of the first things that you can check is the transformation efficiency. This was, I think, already discussed in your previous presentation, but to going back and to make you remember a little bit all of those. So when you have a transformation, you are supposed to have loss. You should expect to have losses. So losses, you transform one energy product into another, you will be losing some of the energy content during the process. So you have here the refinery intake of primary oil products or secondary oil products, again, so just the refinery intake that goes into the transformation process. And at the end, you will have refinery gross output. So due to evaporations, you will have some losses. And when you have refinery intake that are superior, that are higher value than gross output, you have refinery losses. And when you have intakes inferior to output, you have refinery gains. At first, you could think, as I told you, that gains are not susceptible to be happening in a refinery process, because simply you do not create energy like that, and it's require some other things. But when you are calculating the gross refinery efficiency, you divide the output by the intake and you multiply by 100 to get in percentage, and then you have the value in percentage. The unit matters in that subject, especially depending on what type of data you are using when you are calculating your efficiency. If you are using mass unit, you will get losses. You will get smaller output than input. In energy unit, you would also be losing energy in the transformation process, so you will have small losses. In volumes, if you are comparing liters of crude oil and liters of gasoline as the input, you should have gains because of the process making the products lighter. It would expand and have more volumes. So that's when it's important to be monitoring well in your data how you report them and in which units. This is really important for you to check and make sure that you are master of your processes. So after all those refinery activity, we have the final consumptions of those oil products. So due to the specific properties that are given to those secondary oil products during the refinery processes, you would expect that each product is for a specific end use. So this will also help you when you are reporting data. If you see a product that is not in a consumption that you would expect from it, it could be good to check the data or to make sure that you are not missing some information on this. So here, for example, as I told you, for electricity plant, you would see, for example, fuel oil and diesel. This is possible. And you can also see crude oil. This is less common, but this can also be happening. And you can see that in your data. And then you have the input, for example, into road transportations. So there you will have gasoline, diesel, LPG. We did not include them here, but you would have also some biogasoline and biodiesel. Some biofuel that should also be seen there. And let's say what else. For residential, you could have LPG, kerosene, heating oil, and naphtha. So mostly LPG, kerosene, maybe heating oil in some countries for the cooking and heating of the house, of the house. So now we are done with the oil part of this presentation. I will go a little bit quicker on natural gas and coal part, but please do not hesitate to ask your questions. And if you're interested in those subjects, tell us. It would be very interesting for us to know if, and even if you know if there are projects of using those energy commodities within Ethiopia in the coming years, we will also be interested in those information. So now onward to natural gases. So first, for every product, we will see first a world overview of those products, and then we will go a little bit deeper on the data. So gas in the world, USA are the world's largest producer for now. And Russia is the second one, and is a country that is supplying Europe with almost a third of its demand on natural gases. And China and Germany are big importers of natural gas to match their energy demand. Natural gas is mostly used for heat and power productions, and natural gas electricity represents almost 25% of global electricity production. And in Africa, in the total continent of Africa, it's more than 40% of the electricity that is now coming from natural gas. So in the continent, this is a product, an energy commodity that is more and more used, that is getting really important in the continent. Why is it increasing in uses? It's because it's the fossil fuel that has the lowest CO2 emissions per unit burned. So almost 60% of the emissions from coal burning. That is why many countries are using it now as a transition fuel towards the decarbonization of the economies. And it has this cleaner fossil fuel image that is really appealing to many activities. So when we look at the primary supply and demand in the world, so as you can see, OECD demand has been increasing too, especially since the 2000 after the last economic crisis. The demand in general of natural gas has been increasing a lot in the latest year. I told you because of the decarbonizations and the cleaner aspect of this fuel. In Africa, I told you, in latest year, the increase has been extremely fast, and since 1990, it quadrupled in terms of demand for natural gas in the continent. So now, the key driving sectors for the demand, as I told you, the biggest one is for OECD and non-OECD countries, the power and heat generations. This can also be used in industry to generate electricity too, but burned by the industrial sectors. In residential, some cities where we have connections to natural gas for heating and cooking, which can be interesting for many households. And a few parts for transport for specific cars and trucks technologies. When we look at Africa, as I told you, it's even more than that compared to the rest regarding power and heat generations. In Sub-Saharan, even more for power and heat generations. And in Ethiopia, it's none, because for now, for what we know, there is no consumption of natural gas in the country. So there, I will go faster to avoid making it too long for natural gas. But as for primary oil, we are focusing first on the natural gas production, so the receipt from other sources. When you have gas that are separated from, let's say, crude oil, whale, etc. Natural gas production, as I told you, we are looking at the domestic production, so within the border of the country or on the offshore part, onshore and offshore, and the marketable production, so the clean products. Those production can go through a transmission pipeline system for either importation or exportations, and then be either stored or distributed directly to the various sectors, so residential, commercial, power plants, etc. The interesting thing in data regarding natural gas, I told you, that it represents the gaseous form, so that is moved and transported by pipeline, and the liquefied form, the LNG form, liquefied natural gas, that is in bottles and transport in tankers or in other systems this way. So from the production, the gas will go to regasification terminal and will then either be supplied directly to the power plants or will be exported as LNG to other countries, etc. So as I told you, we are focusing here on the dry marketable production. So after purification of the gas from the gas well and the extractions of the natural gas liquids and sulfur and other components that are not necessary or useful in the natural gas products. In this production, we are also excluding vented and flare gases, the losses and the reinjected quantities from the well. All those data are not in our data set regarding natural gas, but it's important to keep them and to collect them anyway because they can be used, for example, in the CO2 emission calculation for a country. The vented and flare gases are really looked at when we talk about how much one country is emitting of CO2. So it is important to keep them, to collect them, and to keep them somewhere. Just in our methodology, we do not publish them there. So as I told you, extraction can be happening in a gas field, of course, but also from oil field and coal mine. They can be captured gas that will be treated as natural gas next. So you have the gross productions, you have the part that are flared or reinjected, of this gross production that is flared or reinjected to keep the pressure in the gas field. From there, you have a processing plant that will extract the NGLs, the natural gas liquid, the sulfur, and the impurities of the gas to only have the marketed production, which will be sell to either suppliers, exporters, etc. Here, again, reminder on when you are managing your data to pay attention to the units and physical condition, especially for natural gas, because if you report natural gas in energy units, it's you just need the calorific value to know to describe your products. If you're reporting it in cubic meters or in other volumes units, you need to specify at which temperature and pressure conditions the measurement of the volume was done. Because as a gas, of course, depending on the temperature and pressure, the volume will change. So you need to pay attention to those. As I told you before, we have also two states of the product that can be reported. So either the gaseous form that will be traded as in pipelines, and the liquefied form that will be traded in LNG in tankers. So regarding the importation and exportation, like for other fossil fuel, we are focusing on the ultimate origin and destinations of the products. So either from pipeline or LNG transportations, we are focusing on which country is sending the gas through the pipeline or through on the boat, and which country is receiving it. Let's say, for example, just on the mine, there will be a pipeline going from Egypt through Ethiopia to South Africa, let's say, for example. Ethiopia will not have to report the transit of natural gas through the territory, since they are not picking any quantities of bad gas into their own their domestic consumptions. So to stop me from talking too much, let's have another small Menti quiz. So so for this question regarding natural gas liquids, we are asking you, well, what are the NGLs, natural gas liquids? So is that the same product as liquefied natural gas, LNG? So NGL will be natural gas in a different form, or are those a waste product extracted during natural gas purifications and of no value, just a waste product that should be thrown away? Is it a mix of gases different from natural gas and more similar to oil products, or something totally else that is not covered in those three propositions? So all right, we already have 3 answers. On this one, we have more various answers. That's interesting. All right, 9 answers. I think we have been covering everyone in the loop. So that question is actually not that easy to answer. And as usual, I recommend when you have a doubt on the definition of when you have a question on the definition of a product, I recommend you to go back to the IRS definition to make sure that you are covering it properly. Regarding natural gas liquids, they are, how do you describe that? Small liquid. When you have a gas field, it's not a bubble of gas underground. You have a mix of liquid and gas in those porous bedrock from which you are extracting. So when you are extracting that, you have gas with bubbles of liquid within them. So that's why we need there's a need of separations of those 2 different products. And in our data, we are treating NGLs as more like oil products than in natural gas. So that's why you need to pay attention to really focus on the dry marketable production of natural gas and to obtain the natural gas liquid productions from the separation the separation plants. So going back to the PowerPoint, now, so just to sum up what we saw on the type of transformation that natural gas can be used in. So the first will be, like we said, the electricity and heat plant. Oh, sorry. The electricity and heat plant, so to generate electricity, heat, or both of them. You can also, those products can be used in other cold gaseous activities such as coke ovens, blast furnace, and gas work. We will see those in the next slide. It's really specific to some part. One thing that is happening though in Africa, and in South Africa in particular, is the use in gas to liquid plants to create synthetic oil products from coal and gas. So those processes can be happening and can generate those products for domestic consumptions. So now we are done with natural gas. We'll go quickly through coal and coal products. As you saw before, there are no coal demand in Ethiopia too, so we will go quickly in this. If you have questions or you want to know more, I invite you to check our other sources that Gianluca already shared with you on our methodology for those data, and to ask us questions if you have specific demand, if you have specific question on those plots. But now we will go quickly. So as usual, first a world overview regarding coal. So coal is largely produced in China and India, so and is mostly produced and used in Asia. They are the biggest importers and user of those products. Why is that? When some people are saying that coal is a product of the past, it is actually still representing more than 27% of the total energy supply of the world. Why is that? It's because it's abundant, cheap, and it has a very low technological barrier. You do not need really high technology, highly advanced power plants or plants at all to use coal. So that's why it is still very interesting for many countries. It is used for power generation, of course, but also a lot in iron and steel production and cement manufacturing, because it allows it more easy with coal to get to high temperature that are needed for those type of activities. Of course, coal is a cheap and abundant product, so it had the default, and the biggest one is it is a large CO2 emitters per unit of energy burnt. It is one of the most polluting fossil fuel that can be used at the moment. Also, to be reconsider on that last point, there are a lot of work that are ongoing right now to reduce the CO2 emissions from coal, such as the clean coal technologies and carbon capture storage that are being developed and worked on to try to reduce the CO2 emission from coal burning. So as I told you before, when we say coal in our data, it is actually regrouping a lot of different products. So we have various ways of classifying those. We can start with what we call the primary fuel, so the original rocks that we extract from mines. So you would have anthracite, coking coal, bituminous coal, etc. So mostly black, brown rocks extracted from mines that can be burnt. And then you have derived and manufactured products, so from various processes like coke oven or gas activities, which are mostly used for, say, as I told you, iron and steel and cement manufacturing, but can be used in other sectors, of course. If you want to see another type of classification, you would have the solid and liquid fossil fuel. So in solid, you have all the primary rocks that I told you about, but you can also have for liquids the coal tar part, which is a subproduct of one of the transformation processes. And finally, on all those transformation processes, you would have gases that are emitted during the transformation, and that those are mostly used directly as the fuels to power those transformation processes. They are most of the time they are recycled this way to not be lost and re-emitted in the atmosphere. So primary coal, as I told you, mostly black and brown rocks, and to distinguish those, what we do is mostly the chemical and energy content that will help to distinguish what name we are giving to each of those products. So given the various carbon content or other element content in those various rocks, you will have various energy content. Here, so the calorific value in kilojoule per kilograms, that would lead to various usage. So for example, coking coal, you would most of the time saw them used in metallurgical sectors. Anthracite, other bituminous coal and subbituminous coal, they are steam coal, so mostly to generate power or to feed some smaller industrial activities, and sometimes residential applications. Lignite, that has a really low carbon content and a higher volatile matters, for example, will be mostly used in electricity energy generation, mostly. So just a small exercise. I think you talked about that already in the previous presentation, but when you have this kind of products for coal, for example, you can have various calorific value, net calorific value, various quality of fuel, even produced within the country. Depending on one mine from another, you would have totally different quality of fuel. So when you are reporting a national value for those, you need to have a national value that makes sense. So in that case, you have here various 3 different quantities of 3 different over bituminous coal with 3 different calorific value. So what we do to get the net calorific value of this total coal consumption in the country, we are using the weighted average. So we are multiplying each quantity by its corresponding calorific value. And we are dividing by the sum of all quantities. And we get here an average, weighted average, that is representative of the part of part of higher quality coal within the total demand in the country. When you are working with those products, as you saw before, there are a lot of different of them, and sometimes it's easier just to make sure that you are reporting in the correct way, to check if they are within the expected calorific value that you would expect from those products. Like, for example, for anthracite, if you have data reported with 20,000 kilojoule per kilograms, it will be a little bit low for anthracite, so could be worth asking your data sources how they got those data and if they are sure that this is anthracite and not subbituminous coal, for example. One last thing also, as you know, we report NCV and GCV, so net and gross calorific value. Regarding coal, most of the time you would have a difference between those two of 5%. It can vary, let's for example, coal. Where's my mouse? There. For example, coke oven coat, actually the difference between gross and net is not that strong, and same for some of the gas, you will not have exactly the same difference, but those are quick way to estimate if you only have gross and do not have net calorific value, or the other way around. You can easily estimate using this quick calculation. So a few last parts on coal before I leave the floor to John Luca to talk about renewables combustibles. So supply and demand in a coal balance, it is actually far more easier than what we saw before regarding oil or gas. You have the production, so as I told you again, indigenous production from within the border of the country. So either from the surface or underground mine, and the derived coal products that are coming from the transformations. These productions would either be imported or would either be exported or go into the stocks, and it can be also enhanced with importation and stock growth. And from all those, you can either use those products in transformation to generate electricity, other coal products, etc. Energy industry own use to support the activity of this sector, and the total final consumption in various end-use sectors. You can also, don't forget, sometimes you can have losses just from the rod falling from the trucks or in other processes. It's important to keep them accounted for somewhere in your balance to have a statistical difference that makes sense in your balances. So we will go to all of those first part in the supply and the rest in the demand. For coal, the balance structure is actually pretty easy compared to other products. So same slide as you've seen before, actually on the type of transformation that can through which coal can go. So you have the electricity and heat generations. You have the coal liquefaction part that I told you before, mostly in South Africa and China, for now in the world, but in other countries they start also to use those. And here you have coking coal that can go to coke ovens to generate coke oven coke, coke oven gas, and coal tar. This same coke oven coke can be used in blast furnaces, so mostly for metallurgical activities, but as byproducts you get blast furnace gas and some other recovered gases. And those energy products are mostly used, as I told you, in energy sector on use. And some other coal products that will go to gas work processes, which is very specific to some countries. And with that, this is the end of my parts on fossil fuels. So I will leave the floor to Gianluca. I hope I tried to go a little bit fast on those to focus on the products that are concerning Ethiopia. If you have any questions, we'll try to answer them. I saw that there are several going in the Q&A, so thank you all for your participation. And Gianluca, the floor is yours.
Thank you very much, Nicola. This was a quite comprehensive view of all the different fossil fuels energy statistics. Now we'll start with renewables products and then electricity, but let's begin with the pool, with the live pool on Menti. So you can just go back to the same page as you were before. If you already entered the code, you don't need. If not, on menti.com, you need to enter 963457, and you can answer to this question. It is about different energy products and what are the most consumed. So you have to order as you did for oil producers, from the first most consumed to the latest most consumed renewable energy products. So I've seen that someone is already answering. We'll see anyway the answer in the slides, but interesting, the first person, we have 4, it's going quick. Hydroelectricity and primary solid biofuels and charcoal are heading to winning, but in the podium we also have all the electricity renewable such as wind, solar, and geothermal. 6 people answer. We have at the same position, I think. I know hydroelectricity now is winning. It's like a race. I really like this pool actually. So there is some people that think hydroelectricity is the first most consumed renewable energy product, while primary solid biofuels is the second. Of course, these are different kind of products because hydroelectricity is about electricity consumption, while solid biofuels are more products that you will need to burn to rise heat. And in the case of Africa, it's mostly for cooking, for example. I think we have 8 answers already. We can leave it like that, but we see that hydroelectricity and solid biofuels are between the first that are consumed, according to the people that answer the pool, and the wind, solar, and geothermal as well are at the 3rd position, while liquid biofuels and biogases are at the 4th position. But let's see in our slides what is the statistics tell us about that. So I'll try to share my screen again. Oop, is this? No, it's not this. I think I have to do this before. Yes. Opla. Here I am. I'm back on my slides. So let's start to see. This is the total primary energy supply, TPS, of the world. So all the energy that is supplied in the world and by product at the left side. So we can see that renewables is about 14% of this total energy supply. That is quite a big number. And we can quickly see that actually solid biofuels and waste is the biggest product in the renewables primary supply. We have at least 9% that is represented in the total energy supply by biofuels and waste. Hydro, as you imagine or well answer, is the second as a about 2.5 of the total global energy supply, and solar, wind, and geothermal are following quite quickly. But if you look at that more on the right side, where we see just the renewables total primary energy supply, and we split the biofuels and waste in the different products, we can see that actually, as the question suggested, most of it is solid biofuels, including charcoal, represent actually 60% of the total renewables energy supply. The rest is liquid biofuels, that is a lower share, and also biogases. As you can see, hydro is not probably, is the biggest source of renewable electricity at around 18% of total primary energy supply of renewable products, followed by wind and solar very closely together. Let's go now to the next slide, where we can see the same figure, but speaking about electricity production. So here we have a clear picture. Interesting again, is also good news. A quarter of the world electricity production is produced using renewables sources. And as we expected, most of it is coming from hydro, as we have seen in the TPS figures. However, we also have a big part of this renewable electricity that comes from solar, wind, and geothermal. That is 6.5% of the total world electricity. So it's quite big. If we saw the same picture maybe 10 or 15 years ago, this number will be much lower for solar, wind, and geothermal. As we can see, also electricity is produced by many other products, but we can see about that later because we have the last session on electricity today. So if we go to answer the other question we saw on the menti.com actually, we can see that what are the fastest growing energy products from the 1990 to now. And we can see that is quite actually impressive that solar photovoltaic electricity production has been increasing 37% per year. So every year we had 37% more solar photovoltaic than the year before. That is quite impressive. Similarly, also wind, but also we can see other products like biogases, consumption or demand has increased 12% every year since the 1990s. This is quite a big figure. While if we concentrate to the biggest one, that was solid biofuels and charcoal, is increasing much slower because it's a traditional use, it's not a new form of energy or technology like solar PV or biogases can be. So it's growing slower with demand and was already at higher levels, as we have seen. There was a question actually that maybe I can answer now from one of our colleagues, from Elias actually. He was saying that we have seen at the beginning a big picture of the primary supply in African countries and the really high share of solid biofuels. And the question was if this is a good thing or not, if I'm correct, an advantage or not. Well, the answer is, for Africa, is quick. This is not an advantage because of many reasons. Of course, when you calculate them, your CO2 emissions for the country, this will be lower because solid biofuels are considered as a net zero emissions, even if we will see that is not always the case because there is some deforestation going with that. This, I think, is a big, actually, disadvantage for Africa because there is a lot of people that relies for cooking on inefficient technology and burning biofuels like wood and charcoal. And this has not only the disadvantage of being inefficient, but it has a lot of health-related problems. Indeed, people that cook with biomass are breathing the smokes, and many people are suffering from the negative impacts on their health on that. It is estimated that in Africa, there are 600,000 people dying every year because of cooking with biomass. So I don't think this is an advantage, it's actually a disadvantage. And indeed, there are many programs in Africa, of course, but all over the world to use cleaner energy cooking technologies, like even just better cooking stoves using biomass, but also using other technologies that are cleaner, like LPG or electricity, etc. But we can see much more of that in the last webinar next week on biomass. So if we continue on the slides, we can see now the classification of renewables. We know renewables, we have seen there are different products. Some are electricity, some are combustibles like the biomass, but how do we classify? Easily we just separate the non-combustible electricity only products. So this will be hydroelectricity, wind, tide, wave, and ocean, and solar photovoltaic. These are our non-combustible electricity only products, for which the first point of measurement in energy statistics is the production of electricity. So for example, when we have a solar photovoltaic plants, we want to know just in energy statistics how much electricity is producing. We are not collecting in the energy statistics framework any energy contained in the sun and then any conversion in the photovoltaic panel. This is an interesting thing, but it's not what is aiming energy statistics. So our first point of measuring energy data for non-combustible products is electricity. Similarly, we have non-combustible but heat primary and electricity secondary products. These are geothermal and solar thermal, for which we can produce both heat and electricity, as you well know. But for them, the first point of measurement at this point is the heat collected. So if you have, for example, a solar thermal plant that produces electricity, in this case, we will not collect only the electricity output, but we will collect or estimate based on the electricity output the heat that is received and collected by the solar thermal collector, actually they're called. So in this case, for geothermal and solar thermal, in energy statistics, we collect as first point of energy measurement the heat that is taken by the devices. Then we have the combustible fuels that can also have a stock change. There are physical products that you can burn, for which we have wastes, like industrial or municipal. And then we have our solid biofuels that include many products such as wood, for example. We can see more later. We have biogases, and we also have liquid biofuels like ethanol or biodiesel that are used mostly in transportation. Finally, we have non-combustible heat only, but this is a bit less important, depending. There are heat pumps, so it's the ambient heat that is collected by the devices that are heat pump to warm up a place, or even on the other way around for air conditioning to climatize a certain environment. But now let's see again the key trends on biofuels. So in 2017, what are the biofuels consumed? This is the full picture, including also the fossil fuels and all the other products in the final consumption. So the industry, the transport sector, the buildings, what are we consuming? We can see that Africa is quite different from OECD or even non-OECD countries. As we can see, and we have seen already in the TPS, so the primary supply, final consumption doesn't differ. There is a big share of biofuels and waste in Africa and in sub-Saharan Africa. Actually, it's about 75% in sub-Saharan Africa where we have biofuels and wastes. With what we have seen before, that answering the question from our colleague Elias, with the related implications on the health, the social life, and environment. Why environment? Environment is because we are cutting trees, and sometimes this is not sustainable, so we have some deforestation. Health, as we have seen, because people that are cooking with biomass are breathing this smoke. And social life, because to collect the wood, people, and notably mostly women and children, spend most of their days going into the woods to collect and pick up wood. So they don't have time to do other activities, for example, studying or socializing or doing other businesses. If you go to Ethiopia, the figure is even bigger. We have 88% of the final consumption that is made of biofuels and waste. If you go more in detail on biofuels and waste, what is included in these biofuels and waste? If you go, for example, in sub-Saharan Africa, we see that 93% of this is mostly solid biofuels, while 7% is charcoal, so a secondary solid biofuels. And in Ethiopia is a bit different, but still similar. Most of this is made of primary solid biofuels, so wood and other kind of wood residues, and 3% is made of charcoal. But if you go in OECD countries, this 6% of the biofuels and waste is very different. Indeed, we have only 60% that is primary solid biofuels, while we see a big chunk of this that is from bioliquids, so used in transportation for ethanols and biodiesel, as we have seen before. So it's a more modern use of the biofuels and waste, or a more modern product in this case. But we speak a lot about solid biofuels. What are them? What does this include? The definition is that are all the organic, non-fossil material that have a biological origin that can be used for heat production or electricity generation. We can have primary and secondary biofuels, as we can see, and we have seen also before. So for the primary solid biofuels, we can have wood and woody materials, as we have seen before, but we can have also some residues from the agriculture, like bagasse, from the production of sugar, from sugar cane. We can have rice husk. When rice is produced, there are some residues that can be used for energy production. From the olive oil as well, from the production of olive oil, we can have some secondary products as well, etc., etc. We can have animal waste that can be used also for heat rising purposes. In terms of secondary products, we have the main one that is very widely used, as we have seen in Africa and Sub-Saharan Africa, that is charcoal, which is produced from wood products, as we will see just in the slide that is coming. So in charcoal kilns, that are devices to transform wood in charcoal, we produce our charcoal amount. There are different types of charcoal kiln. This is a very important topic actually, because depending on the technology you are using, the efficiency of transformation is very different. And so the amount of food you will need to produce a certain amount of charcoal can change drastically. Actually, as you can see here, the efficiency, so the output divided by the input in energy units, can be very different. You can go from 20% in traditional earth kiln to produce charcoal to 70% to the more industrial and efficient ones. So what does it mean? So when we have 20% of energy efficiency, that means more or less, based on the net calorific values, of 10% mass efficiency, means that you will need 100 kilos of food to produce only 10 kilos of charcoal. So this is huge. And this also is one of the reasons why deforestation is increasing, because people are moving to the cities, so they're using more charcoal than wood now, but the production of charcoal implies a lot of losses. And so the requirement of a higher amount of wood. So this is really important, but we'll speak about that in a webinar that will be focusing a bit more on biofuels. Now let's go to see a bit more about electricity. This is also a very important topic. And I would like to start that by, again, having a small question. Here we are. I hope you can see my screen. I'll try to put the question right now. This is our question. In your opinion, which is the sector where we consume the most of electricity globally? I'll let you some time to answer the question. So we have residential or households, the industry, the services, so all the commercial buildings, etc., or the transport sector. This globally, so around the world. We have only 3 answers. Someone else? Still the same code. For answer, most of the people for a moment are saying that most of the electricity globally is consumed in the industry sector. We'll see the answer in the graphs that come in the slides after. So yeah, definitely people have a really strong opinion that industry is the most consuming for electricity. It's a very good point. And now we can see the same question, but for Sub-Saharan Africa. Where in Sub-Saharan Africa most of the electricity that is supplied is consumed? Industry and households again. Of course, transport is still a low sector demanding electricity, but you have to remember that in some countries there is also electric trains or metros or etc. that requires quite a big amount of energy. But still, for road transportation, electricity is quite small. Even for Sub-Saharan Africa, we have a majority of people saying industry, but some people are actually telling that residential and household are a big sector demanding electricity. So let's go back to our slides now. Just to here we are, and hopla. So now let's see this graph that is quite interesting about electricity. And as we know, electricity is booming. We are electrifying everything. From the 1990s to now, we have so many more electric devices, phones, computers, etc. we didn't have before. So as we would imagine, electricity demand has been growing very strongly. Indeed, in non-OECD, as we can see from this graph on the red line, since the 1990s, we have seen a growth of at least 3 times. While in the OECD, we increased by 50%. It is still a big growth. The global electricity production is 25,000 terawatt hours. What does it mean? This is a really big number. To produce 25,000 terawatt hours, you will need to put, for example, 4.3 million wind turbines. So imagine how big this number is. Or 10,000 nuclear reactors. This is like a huge number. So the electricity produced today globally in 1 year is very, very big. So we've seen Sub-Saharan Africa has a really similar consumption trend, let's say, increase than in non-OECD, so growing more or less by 3 times, in this period, these 30 years. But if we take Ethiopia, actually, we have seen an increase of 12 times from 1990. So this is very, very big. Ethiopia's electricity sector since the 90s has been developing very, very fast, as you can see from the graph. It's one of the countries in the world where electricity demand has been growing the fastest. And this is for various reasons, because you develop the infrastructures in your countries to produce and deliver the electricity, because demand is increasing, access to electricity to people that were living without access in more remote areas increased quite a lot. But how this electricity is produced using the different products? This depends highly on the resources that are available in your countries and what are the cheapest as well as political decisions and choices. For example, in France, there is a huge production of electricity using nuclear, and this was because of some policies and political choices that has been made some decades ago that brought to the construction of nuclear plants, and now France relies quite a lot on nuclear. But some countries like Ethiopia that has very good hydro resources, so good rivers passing in Ethiopia, as we know also from new plants that the country has to increase also the production. 93% of your electricity in your country is produced using hydroelectricity. And this is because you have the resources. As you can see, in the OECD in average is only 13%, because there are less resources, but also because the demand per capita is higher, so you will need also other sources to compensate. As you see, Ethiopia electricity production is quite interesting because you have it's mostly renewables, is a good news. And you have practically, it's not visible in the graph, practically no production from combustible sources. I think there is a small production from oil, if I remember well, but it's negligible compared to the hydro and also the solar and wind production. This is also because the consumption per capita in Ethiopia is still very low compared to other countries. And so if the need increase, you will probably need to, if people start consuming more electricity, so people have more access to electricity and consume more because they get wealthier, you will need probably to plan on different sources as well, if hydro and solar is not more enough for the whole country. But as we know, Ethiopia is planning to put in operation a new dam that is quite famous around the world for the news, and this will provide much more electricity, and so you could plan more access to electricity to the people of your country. That is also a good news, and this is also clean electricity. But seeing in figures, as you can see, OECD and non-OECD represent more or less each half of electricity generation. Actually, non-OECD a bit more, 57%. You can see that Sub-Saharan Africa represents, even if it's most of the countries in Africa, only 30% of electricity production in Africa, and Ethiopia represents 6% of electricity production in Sub-Saharan Africa, excluding South Africa, of course. Interesting to notice also is that in OECD countries that don't have the same solar resources as Sub-Saharan Africa, for example, the share of solar electricity and wind is much higher than in these countries. So there is a big potential in Africa and in Sub-Saharan Africa to develop solar and wind electricity. But now let's go on where the electricity is consumed. That was the question we have been answering before. I think most of you answered the industry in the world, and it's actually true, because if you see non-OECD countries, 50% of electricity is consumed in the industry. Even if in the OECD countries, we have 1/3 in the industry, 1/3 in services and commerces, and 1/3 in the residential. But if you put together residential and services, considering them buildings, we can see that in OECD countries, buildings consume more electricity than any other sectors. If you go in Sub-Saharan Africa, the figure is a bit different, and we see that for example, 36% is consumed in the industry, but most of that is consumed in residential. These are only percentage figures and shares, and we have to take into account the fact that the electricity access in Africa is really low, both in the household, so in your homes, but also in the industry, that the industry sector is not as developed as other countries, and this is because of the quality of electricity in the region, where the industry cannot rely on a continuous and high quality electricity supply, so it's not as developed as in other countries. So the absolute level of demand is lower than in other regions in the world. But speaking about access, let's see some figures of residential electricity access. As you can see here in the vertical axis, we have the access in terms of population percentage that have an electricity access. And in the horizontal axis, we have the GDP per capita, the GDP PPP per capita, so purchase parity. This will tell us, let's say the GDP per capita can be an indicator of the wealth of the country, so how much money is generated in the country per person. And the access per population tells us how many people has access to electricity. This is in 2010. You can see that Ethiopia, in red, had more or less 20% of the people with access to electricity. And if we can see the same figure today or in 2017, can see that Ethiopia increased to 50%. This is one of the reasons also why we have seen a boom in electricity, the reason or the cause why we have seen a boom of electricity demand in the country. But interesting to notice from this graph is the relation between wealth, so the GDP per capita, and access to electricity. They are interconnected, so increasing the wealth drives higher consumption per capita of electricity, and vice versa. When you increase access to electricity, people will be wealthier. So it's a really important topic. And this is why all the countries as Ethiopia are working a lot to increase the amount of people that have access to good quality electricity. But we'll speak more about that next week in another webinar. Now let's see, how do we report electricity? What are the different flows, supply and demand? So we have the production of electricity in the plant, can be using fuels or can be direct electricity production through wind or photovoltaic, for example. We have our gross production of electricity, this is the total output. We have some of this electricity needed by the plant to its own functioning. And so we'll have our net production, that is the gross minus the electricity needed by the plant functioning. This net production will go to our transmission and distribution networks. Some of it can be used for pump storage, for example. I think in Ethiopia can be something interesting. So pumping up some water to store this energy to produce electricity later when demand is again rising. Some can be traded, so sold or imported from other countries. And then we'll have all our electricity that go to our final consumption. After, of course, losses that will happen in the transmission and distribution networks because of the state of the grid, because also of, as we have seen in other webinars, in some countries there are some non-technical losses that are meant mostly on thefts. So people that are connecting illegally to the distribution network to steal the electricity. And then we have the final consumption in the different demand sectors, as we have seen before. We have some other figures that you like to collect in terms of electricity that are the capacity by technology of the different power plants. So how much capacity you have for example, the hydro, how much capacity you have on coal or nuclear, and also the peak load. So what is the maximum capacity of the demand in your country? We can then classify electricity products or sources by primary and secondary. Primary is the one we have seen before, mostly renewables products for which we measure electricity as the first point in energy statistics. And secondary are all products that requires a transformation. So combustible fuels, then we have nuclear, geothermal, and solar thermal, for which these last three, the first point of measurement is heat, as we have seen before. Then for the producer of electricity, so the power plant, we can classify them by two different types. The main activity producers, that are the plants that generate electricity for third parties and as their primary activity. So their business is producing electricity and selling to other people. And then we have auto producers, that are these plants that are generally smaller, for which the generation of electricity is not the main business and is partly or entirely due for the own use of their activity. For example, if you have a refinery can build its own small auto producer plant, for example, using refinery gases to produce electricity that will be used by the refinery itself for its own functioning. So this is an auto producer. And it's a bit different because the business that it does, it differs from the main activity producer, for which producing and selling is the first and main objective. Then we have three types of plants as well. We can classify any main activity and any auto producer plant in electricity only plants that only generate electricity, in heat only plants that just produce heat, and in CHP or combined heat and power plant, which produce both electricity and heat. What we can do for electricity plants, we can calculate the efficiency as you've seen before. This is a good tool also to check that our data are correct. So do some quality checking by comparing the input and the output. We know that the ratio between output and input is never higher than 100%. It can differ by type of technology and fuel used, and needs to be calculated in the same energy units. In these examples, we have 100 units of energy getting in, 20 units of electricity, and 45 units of heat. So this is a combined heat and power plant. And if we calculate the efficiency, we sum the outputs, so the electricity and the heat, in the same energy unit, and we divide by the input used to produce this energy. And we see that this CHP plant has an efficiency of 65%. Why is that? Why is not 100%? Because there is always some heat that is lost during the production of electricity. As I say, we have to use the same energy units and good calorific values, of course. Then we have the concept of net maximum capacity, that is, in my country, and probably by technology or by fuel, what is the maximum potential power that can be supplied with all the plants that are operating and running in my country. And this, for example, in the IEA, we use the 31st of December because we use the normal year, but some countries can use other timelines like fiscal years. But it's recommended that all countries use the same definitions of year. Then you can calculate the capacity factor, that is how much my plant produced divided by how much was the maximum potential production. So if it was running a maximum capacity the whole time, and this is also a good checking tool. So if we collect the capacity in megawatt or in gigawatt data, and we have the production in gigawatt hours, we can see if our data are correct just by doing this calculation of the capacity factors, because if it's higher than 100%, already we have something wrong, or the capacity or the production. If it's very low, we have to check why. For example, a plant has been out most of the year, it's possible, or an hydroelectricity plant was not running because this year we had no much rainfalls, so the production was lower than other years. But it's a good practice to follow, calculate, and track the capacity factor, and use it also as a check of data quality. As we have seen before, we have a gross and net production. We have seen in the main supply and demand flow chart. So what is the difference? As you have seen, the own use, the plants need some energy or electricity to its own functioning, for lighting, for air conditioning or space heating, and for other, for the functioning of other devices, mostly power electronic devices. And then we have the net production, that is the difference. It is the electricity, or the amount of electricity that really arrive to our grid infrastructure. We can calculate the on use as a percentage of on use by production. And this is also, as we have seen last week, some weeks before when we did the first webinar, we have seen that that is an important indicator as well to check the quality of the data. As you've seen, it shouldn't vary too much year by year for each plant, and is very often low at around 5%. Then we have another important part of the electricity value chain, that is the losses in the transmission and distribution. As we can see here, we can have losses in the transformation of electricity. We can have losses in the transmission lines, around 2–4%, and again, in the transformation to lower voltages, and then in the distribution lines. So we have a total, in general, of technical losses that can range from 5 to 15%. It depends on the state of the grid. It depends on the average temperature of the countries. It depends also on other factors, as for example, the non-technical losses amount. If there are many people stealing at the distribution network electricity, our losses will increase if we calculate the losses as the difference between the electricity that is supplied and the electricity that is produced. So you can see technical losses should be lower than 10%, but for some countries where thefts and the grid maintenance is very low, so the state of the grid is not very good, and so losses increase, we have seen up to 30% of transmission and distribution losses. Again, this is the losses as a percentage of, sorry, this is still in French, as a percentage of demand is a good indicator of data quality, because if you have very high variations, we can try to understand why. Sometimes there are reasons, but it's important to track it and verify why. Then we go to another important part of electricity, that is the trades, because this is different than what you've seen for the other combustible fuels mostly. Why is different trade? Because it's more difficult to track electricity than it is to track a barrel of oil or a specific amount of natural gas. And indeed, for electricity, we report on the basis of border crossing, not origin and destination as for the other fuels. So we will include in all trades also the transit. This means, for example, Portugal is these green countries and France is these blue countries. In the middle of the two countries, we have Spain, that is here in yellow. If France buy electricity from Portugal, this electricity passes to Spain. How is this reported? So Portugal will report exports of electricity to Spain. Spain will report imports from Portugal and export to France. And France will report only imports from Spain. So you have seen this is a bit different than from the other fuels, but it's important also that we clarify it clearly. How can we collect electricity data? It's similar to the other fuel, of course, but we have surveys. So we can go to the producers, how much electricity are you producing, what is the capacity of your plants, what are the transmission and distribution losses from the operators that you have noticed, etc. We can have market operators, electricity enterprises, means like companies that consume electricity, and households or other buildings like commerce, where we can track instead the demand of electricity. Then we have administrative data. There are energy regulators, custom offices for trades, for example, data collected from different programs and policy implementation. For example, on mini grids, because in Africa and Sub-Saharan Africa, we know that is a rising importance, the electricity that is not connected to the grid. So there are also other sources to have fuel pictures that are not only the main power producers, but we'll have, for example, some programs that are building mini grids, and there we'll have some other electricity that needs to be taken into account. So other potential sources of energy data, direct measurement, that's of course, conventional smart meters for electricity. As we know, electricity is measured because it's easy to measure, and also because it is commercialized. So we need to track how much we sell, how much we consume to bill this amount of electricity. And then there is also estimation and modeling as a last resort if you don't have the data. For example, if we know the plant capacity information of solar PV, we could estimate based on different inputs like the solar irradiation in the country or other important information, the electricity generation. We arrived at the end of the presentation today. We have been maybe a bit long, but I think we cover many topics. I hope you enjoyed today. I don't know if there are questions right now. I don't see any. I don't know, Nicola, if you see some.
Yeah, actually, I tried to answer some of them before, but there are two that could be discussed, I think, at the end. So let me find it. So one from Ebisa. So the question read, in Ethiopia, biofuel consumption is around 88%, which is big. But this percentage is estimation, assuming that the biofuel consumption data is increasing in every year linearly. But we do not know whether it is correct or not. Even still, no, we are challenging to collect biofuel data and also to estimate as well. Would you mind if you say something about which method is good to collect biofuel data, or which method is good to estimate the biofuel data depending on the historical data?
This is actually a very, very good, important point. As we know, and as you're saying, right, even not only in Ethiopia, in many countries, tracking traditional biofuels is very difficult because there is not a real market. Most of it is picked. And that's when there is a market, it's not an official market. So people are selling charcoal. It's very difficult to track. And this is true that not only Ethiopia, many countries are doing estimation that are many times linear, depending on population or other proxies. And this is probably not correct because there has been a shift. There are many programs and many people now are cooking with LPG. Many people are cooking with other fuels, or they are using more efficient cooking stoves, so they require less wood to prepare the same meals.